Okay, we are live.
Excellent. Hi there, welcome to our April installment of the Dance Talk series. We're very excited today to have Tim McKay here from the University of Michigan. I'm very pleased that he's made time to spend with us even during their big bicentennial celebration that's going on now. And so Tim actually initially did his work in astrophysics, but like many physicists, he is using his modeling skills in the learning analytics space now, and he'll be talking to us about personalization. So we're very excited about that. I think Shri will add some to what I've said.
Yeah. Thank you, Tim, for joining us. Tim actually identifies as a data scientist. So as Callan mentioned, he's worked in astrophysics in the past. He's a Arthur F. Thorneau Professor of Physics, Astronomy, and Education at the University of Michigan. He's worked on large data sets using the Sloan Digital Sky Survey and the Dark Energy Survey to study the growth and nature of the cosmic structure and the expansion history of the universe. And his work with large data sets also transferred well into work with learning analytics, which we'll be interested in. In 2011, his team created the eCoach, which was a computer-tailored support system. And in 2014, he launched a campus-wide effort called the Rebuild Project, which was promoting the use of data and evidence-based methods in teaching courses, introductory STEM courses specifically. And most recently in 2015, he started the Digital Innovation Greenhouse, which incubates a lot of EdTech projects in the University of Michigan's Office of Academic Innovation. And I think we're going to be hearing a lot of exciting projects that they are doing in the Digital Innovation Greenhouse that might be of interest both to the practitioners and the researchers in our audience. And I was introduced to the work, the wonderful work that Professor Tim McKay is doing through a MOOC that he taught called the Practical Learning Analytics MOOC. And I'm sure he has a lot of interesting things to share with us today. So without further ado, here's Professor Tim McKay.
Okay, great. Thanks, Shri, for the introduction, Carolyn. It's nice to have a chance to talk to this audience too. What you just said about research and practice is really appropriate for this conversation, because one of the roles that I see myself playing is in drawing together the communities of research and practice around both evidence-based teaching in general, and especially around the use of data and of the kinds of tools that data make possible in education. And I'm thinking a lot about how to bring research and practice integrated ways so that we can advance both more rapidly. And that's kind of a part of the theme that I'll talk about today. So I'm going to go ahead and share my screen so that you all can see the slides that I'm going to present. And I'll talk you through these for a while. Okay, I'm going to share my screen and put up the talk. All right, I want to talk about academic innovation, particularly around the use of data and information technology that puts that data to work, and how we've been working academic innovation in a place we've established here at the University of Michigan called the Digital Innovation Greenhouse. I want to expand a little on the story that Shri told you about my background, and tell you that I came here to the University of Michigan, well over 20 years ago in 1995, as a very typical physics professor, as an astrophysicist, working on a variety of observational projects. And that's a kind of relevant thing to mention, because astrophysics is necessarily an observational science. We don't get to do experiments which collide galaxies or create universes. And I'd say that's relevant because I learned in astrophysics how to draw causal inference from purely observational data. It's not an easy thing to do. It's much easier to draw inference from experimental data, but it's also not impossible to draw inference from observational data. That's relevant for the work I'm doing now, because a lot of our education work is also at least quasi-observational. We don't often get to conduct full-scale random controlled trials, for example, but we still can draw a lot of inference from observing what's going on in education. Through astrophysics involved a lot of work on big data cosmology, measuring hundreds of millions of galaxies in order to try and understand how those galaxies come to be the way they are. I also spent some time hunting rare and brief signals, things like gamma ray bursts and supernovae. So a lot of different kind of generic data science problems. As science emerged over the last decade or so, I realized that both I and all the students that I had ever trained really were data scientists working on drawing inference from large data sets. And so along the way of doing astrophysics, I really just sort of built the sensibility of being a person who is intrinsically drawn, especially when they're like accessible, when they've been assembled already and one can pull them in and begin to draw inference from them. I really got shifted to working on education projects, though, because my career took on another aspect as an academic administrator, and I spent 8 years running an honors program for our College of Literature, Science, and the Arts. This is a program of about 2,000 students across all the disciplines in this liberal arts college, so everything from classics to psychology to pure math and everything else included. Because I was now responsible for students from the time they were admitted to school to the time they graduated, and because they were working across all these disciplines, I realized just how limited my knowledge of what was happening was. And being a data person, I wanted to get some data to be able to better understand what was going on. And that's what really gave rise to all my work in both learning analytics and in thinking about how to do education technology interventions. Okay, so that's just a little background. I come from this background as a big data person working in astrophysics. As it turns out, I've now shifted that attention toward education projects, both for myself and in an effort to pull that kind of activity along at the University of Michigan. So let me start with just a kind of large-scale framing. I see the 20th century beginning with a big industrial revolution in which we became capable across a wide array of technical and social activities of doing things at scale. Public higher education at institutions like mine joined in this industrial revolution at the beginning of the 20th century. Here at Michigan, we increased the enrollment between 1910 and 1950. We increased the enrollment by a factor of 10. So we really exploded in scale. And the way we managed to do that explosion in scale was to adopt a variety of industrial techniques, industrial approaches that included things like standardized testing, but also accounting mechanisms like credit hours, letter grades and GPAs, bundling like majors and minors that allow some choice, but also create some structure. We just set up the of higher education in that industrial era in order to accomplish the kind of growth to scale that was natural to pursue at that time. About as well as it could have been done in the 1920s. A lot of really smart things were done that enabled us to educate here at the University of Michigan, about 700,000 people over the last century. So that's a remarkable accomplishment, something we should be proud of. It's also, however, far from perfect. Around the 1970s, people began to recognize that this industrial mode of education really wasn't perfect. True that all of our students were interchangeable parts that we could put through an identical system equally well, but that we really needed to begin to think about personalizing education, even at scale. And so in the 1970s, you see a bunch of new things emerge in higher ed and become popular across the whole sector. I'm showing here in this figure a Google Ngram view that shows the prominence of certain phrases in all the books that Google has scanned. And the phrases I've chosen here are freshman seminars, and learning communities, and academic advising. And you can see that all of these things are really absent before about 1970. They begin to take off, and then after 1990, they really become much larger. Effort to personalize higher education, even while it's operating at scale. The problem with this kind of approach is that doing it fully at scale is really difficult and very costly. All of our campuses spend a lot of money on these kinds of activities now. And despite spending a lot of money on them, we find that they actually reach most students quite thinly. On our campus, for example, it's not uncommon for a student to graduate having visited an academic advisor only 2 or 3 times during their whole career for half-an-hour appointments. So it's not doing a lot of adaptation to the individual. It's very important and it's certainly worth doing, but it's not accomplishing the whole goal of personalizing. So this is what we might call boutique personalization, a good effort trying to bolt on to the industrial model of the 20th century, some efforts to personalize. Now, today, in the 21st century, we live in a really different era, in an information era. At this point, many, maybe even most, educational activities are digitally mediated. That means that the activities that students and faculty engage in the course of education leave a record, which allows us to know more about our students than we ever have in the past. That information enables us to think about personalizing education at scale, really knowing a lot more about each individual student. And in addition to having that knowledge, having the kind of affordances that allow us to put that knowledge to work in personalizing, changing the experience in response to the background and goals and current state of every student on our campus, no matter how many of them are here. And that kind of large-scale goal of personalized education at scale is certainly something that we hold out as an important goal here at Michigan. Okay, if you think about this opportunity that we have this big pile of information that tells us much more about what's happening on campus. And you could start by thinking of it as information about the student. We have all this information. What are we going to do with it? How are we going to put this data to work? When I think about this question, I imagine a spectrum of information agency. And no doubt that's just the very first order way of thinking about this. It's really some kind of higher order space of information agency. But let's start with just a kind of two-dimensional spectrum that could inform what's going on campus, that could help people make decisions, alter their behaviors, alter the systems that we have. How are you going to put it to work? And I think on the two ends of this spectrum of information agency, we have two extremes. So on one hand, on the left-hand side of this figure, we could give this information, all the information, directly to the people who need to act. We could give it to advisors or faculty. We could give them the data and let them interpret it. And there are a lot of great things about this approach because it puts the data into the hands of the people who really do have to make the decision, and they actually know in themselves a bunch of other information that may not be present in the data and would modulate the way they would respond. Okay, so there's good reasons to put it on the left-hand side. The problem is the people on the left-hand side don't all have all of the skills that might be needed to draw inference from this big complicated data set. They may not have the time to be able to do that. And we would then be multiplexing the effort in the sense that some questions, and if we could answer those questions for all students, they wouldn't have to spend the time of doing it each individual, right? So there's some drawbacks and some strengths of giving the information directly to people. On the other side of the spectrum of information agency, you can imagine an opposite approach where you never give the information to the individuals who need to make decisions. Instead, you give it to some experts. And you have those experts interpret the data for students and advisors and faculty. And you can think about this information space being higher ed, but you could also think about it being the health system or any other place where information should be informing how people are making decisions. It always exists, where you might give it only to experts and let them make the decisions, or you might give it only to individuals and let them make the decisions. The right solution, I think, of course, lies somewhere between these two extremes, and that's the solution that we have usually selected in the past. So we might instead give the data out in both directions, allow individuals to get at the data as much as they want to ask and answer their own questions, but also have experts look at this data, interpret it, and try to shape the decisions that individuals would make, using the techniques of behavioral science and choice architecture, things like nudges. This may sound, to some people, this kind of new information-rich way of doing this sounds a little creepy, like experts are going to decide what to do, or algorithms are going to decide what to do, and they're going to tell us what to do. But it's not completely different from where we have always been. If you imagine the task of an academic advisor, they've always done work like this, where the academic advisor has a lot of information, digests it, and turns it into advice that they give to the individual student. They don't make the decisions for the student, but they do strongly shape those decisions in the way that they speak to the student about the advice that they're giving. So I think the thing we're doing here isn't utterly new. We should think about our historical experience with things like advising, when we think about how to shape good systems along this spectrum of information agency. Okay, we have come to think of our university as a really giant education laboratory. Every year we bring about 7,000 freshmen to this campus, and we put them through a system in which we have made an enormous array of choices about what we should ask students to do and how we should interact with them while they're in that system. We monitor how they move through that system, placing challenges in front of them and getting the authentic product of their work as an opportunity to reflect on their success in those challenges. This is happening, at a very large scale across 9,200 classes on our campus. And because that activity has become digitally mediated, it is now the source of a very rich pile of data about what happens when you put students like these into this kind of educational circumstance, interact with them in the way we're doing. We can learn from every one of those acts if we take advantage of this data, try to gather it up and build around it good procedures for understanding the outcomes that are coming out and then feeding the results of that back into practice so that they might improve, right? More and more of our campus as a place which is engaged in continuous educational research and development. Discover new things, to test them in a real, authentic environment, the very environment which we aim to improve, and then to iterate and try and improve things. Complicated things are involved in realizing this vision of a campus as an education laboratory. Not least, it's crucial that all the people who are engaged in this community are aware and understand the nature of the experimentation that we're doing here, that they acknowledge that we've in fact always been doing experiments with education. We just haven't always had a good system for learning from those experiments and feeding the results of them back in a really robust way into our system, and we're now establishing that. So a lot of work, a lot of interesting work that I would love to talk about in another context, going on to try and think about how to create this kind of learning higher education system, one which continuously learns from practice, feeds it back into practice, and improves continuously. So maybe a good talk for another day. I just want to point out here that that kind of effort is large, complicated, and one of the things we think a lot about. Okay, I want to talk about this digital innovation greenhouse for most of the remainder of the time. So let me explain where it came from and why it came to be. What was happening on our campus is that we have 6,000 faculty members on this campus, and they engage in a wide range of innovative activity in their scholarship, but also in their teaching, which for some of us is the scholarship that we do as well, of course. So we had things happening on campus, like a number of faculty innovators who had seen the opportunities provided by digitally mediated education, created tools that aim to take advantage. Tools aimed at making education more personal, or maybe making it more engaged, making education more lifelong, aiming at different goals, but creating tools bolted onto this kind of information that existed. These faculty research teams would build a tool, make it work, test it in an education environment that they could access, and demonstrate its effectiveness. So they were doing the kind of research part of getting a tool started, demonstrating that it not only could work, but at least in some contexts did work and lead to positive outcomes. For that, they would talk about it, of course, with all their peers, and everyone on campus would want to adopt it. And this is where we really faced a challenge. Because the research teams that create and develop projects like this lack the skills, interests, or rewards that are required to take an innovation and grow it to an infrastructure scale. Researchers are supposed to do the research and establish new principles. They're not typically well kitted out to do the kind of development work that's needed to turn a good idea from an innovation into infrastructure, or let's say from an invention into something more like a product. This is a very typical problem in the world of innovation. People often refer to the gap between an invention and a product as the entrepreneurial valley of death, right? A place where good projects go to die. And we certainly had seen that happen on our campus. Really good ideas emerge, grow up, be demonstrated, and then fall apart because we didn't have the structures needed to keep them alive. Innovations like this need a nurturing place that they can be brought into, a place where they can mature, both technically and in conception, so that they will be working in the right way for the audience that's trying to use them. They can be spread with the kind of support for spreading that's required, real effort going into identifying the communities that would benefit from a tool like this and then convincing them to participate both on campus and off. We needed a space like this. And so I proposed to the university in 2014 that we should create a new unit on campus, an experimental unit, something to try, something called the Digital Innovation Greenhouse. And so that's what the greenhouse is. Its goal is to take good ideas that emerge on campus and grow them from the innovation scale to the infrastructure scale. And while there are many specific goals of these different tools, our general goal is to be able to personalize education as much as possible, even when we're educating at scale. So I should mention that we selected the particular kind of metaphor that we're using here of a greenhouse because the alternative kind of name you might use for this would be something like a business accelerator. That's kind of the model that it's built on, the business accelerator model. But on my campus, and particularly in our College of Literature, Science, and the Arts, business terminology is not favored by the faculty. They really don't like it. So we chose instead a metaphor that we thought would be much more comfortable for our audience, the idea of a greenhouse. Because who can really object to a greenhouse? You know, you bring your seedling to us, we water it, we give it organic food, we put it in a sunny place where it cross-pollinates with other projects, and eventually we grow it up and plant it out in a field. So just a nicer metaphor for the exact same kind of operation with a lot of exactly the same kinds of pieces involved. The way DIG works is kind of described in this diagram here. So the greenhouse is the big box in the center. That's where the activity takes place, though comes first from the university teaching community that you see on the left-hand side of this diagram. We take good ideas into the greenhouse from the university community. We bring with them the faculty innovators who created these projects, so we will work closely with those faculty innovators. And we also draw into the greenhouse community the communities of practice on campus who are actually going to use these tools. This is very important for us because it allows our team to develop the tools that are brought in very close conversation with a testing community that is, in fact, our authentic environment. So as we're developing tools, we don't have to like develop a version of the tool and only then get to be in communication with our audience. We can actually be in communication with our audience throughout the entire process. Very valuable thing for us. The people who are employed in the greenhouse are kind of represented on the lower right-hand corner of the greenhouse. It's a set of people with different skills that all contribute in important ways to the functioning of the greenhouse. It began with software developers, people who could grow the technical side of these projects, mature it, so that it would go from something perhaps built by a graduate student that you could make work in a class to something which was built by professional software developers and could be easily used at scale, perhaps across a whole campus or even beyond. So that's software developers. We also discovered very early on the crucial importance of user experience design for any kind of education technology. And so we have a whole team of user experience designers who work on these projects as well. They work in close collaboration with user testing, on the actual users, the faculty and students who will be using our tools. And they also include some visual designers. It turns out if you want to make tools that people not only are used, but are actually eager to use, good design is crucial. You can make a tool whose function is great, but whose an interaction with the individual is not, and they really won't use it. So design is very important. There are two other big roles in the greenhouse. One is behavioral scientists. So one thing that I have learned is that my job as an educator isn't really about shoveling content into people's brains. You know, I kind of wish I could do the work for them, but I really can't. It's more about shaping an educational environment in which students will be put into interaction with the kind of content and challenges that are needed for them to learn. They will do the things that they need to do in order to learn. So I'm really about shaping their behavior, trying to get them to do the things that they need to. And in doing that work, I've come to consult much more often with people whose career focus has been in behavioral science, understanding how to help people do the things that they feel they've chosen to try to do, but that might be difficult for them to accomplish. We work with behavioral scientists quite a bit. And finally, the last role, it's not actually listed here on the slide, is innovation advocacy. So once you have a good idea, it's very important that that idea get communicated well to the audiences that might benefit from it. It's a two-way street. It's not like just marketing it or sending out messages. It's actually entering into conversation with those audiences so that we can find out our tools might be able to help them and in what ways there are things they need that our tools don't have yet and which we might want to work tools. So innovation advocacy is an important part. The general idea of the greenhouse is that things come from the university teaching community into the greenhouse. We mature them there for some time, and then we take them out of the greenhouse and send them off to our university IT organization to simply operate them at scale. They're no longer being developed, or if they are, it's in cycles rather than continuously, and then they get operated at scale by our more standard university IT organization. Some of these tools that we built will go to even larger scales by various means, including university consortia like the Unison Consortium, and potentially some of them will be commercialized and go to larger scale than our campus in that way. Large scale structure that we set out to build with the Digital Innovation Greenhouse. We have since learned that there's another really interesting and I think important branch, which you see on the right-hand side of this figure. Once you create an environment where you are using data-rich tools in interaction with large numbers of students in real educational environments on your campus, you've actually created a great research environment. A variety of researchers on our campus recognize the opportunity provided by this kind of learning laboratory that our campus has become, and they're starting to do externally funded research using this research opportunity as a space to do their work. Most of these researchers are like myself, interested directly in education research, but some people are interested in other things. For example, we have a researcher whose work is really on how to increase engagement with online communities. A very general question. Our online communities that are present on campus are one example of such online communities. And this School of Information professor is able to do research on increasing engagement with online communities in the particular environment of our campus because it's kind of well-instrumented space that she and her team can plug into relatively easily. So once you create these kind of structures, you're also providing research opportunities. A new thing that we've learned. Okay, so that's the general structure of DIG. Let me give a little bit of history of it. So we started in November of 2014 when we submitted and received what was called the Transformation Grant from the University of Michigan's Third Century Initiative, something associated with the bicentennial that Carolyn mentioned at the beginning of this talk. It gave us a chance to try this experiment, to set up such a facility and see whether there was really demand for it. We knew that there were several projects that we would bring in the first case, and those three projects were the Academic Reporting Toolkit, eCoach, and something called Student Explorer. So we had an initial group of things, but we also believed that if we built this structure, brought to it a variety of other projects, and that those other projects would bring, in some cases, their own resources to allow the expansion of the greenhouse. In May of 2015, we hired our first 3 lead developers and put them into a space underneath a parking garage here on our campus. The roof was literally the ramp of the parking garage, so it felt very startup-y. You know, a lot of those startups happen in garages, and this was very much that kind of feeling when we started. We began launching our first tools in September of 2015. At that point, we were using the eCoach tool to provide tailored feedback and encouragement to about 3,500 students in a set of different places. The emergence of DIG led to new projects joining. And so in November 2015, there were 2 new projects, 2 large projects that joined, one called GradeCraft and one called MWrite. I'll talk more about all these projects in a little bit. They joined in November of 2015. Continuing on toward today, in January of 2016, we began to really expand the team of people who work for DIG, bringing in our first user experience designers, another developer, and a behavioral scientist for the first time. New projects were joining like Policymaker. In March of 2016, we launched our first large-scale academic reporting toolkit tool. I'll tell you about that in a little bit. We began expanding eCoach in the summer of 2016, and by February of this year, commercial versions of the GradeCraft tool. We'd actually taken one of our tools and transitioned it out of the greenhouse. It had matured and moved out, and we have new projects joining us and so on. So DIG was born in May of 2015 underneath this garage, and this picture you see on the left-hand side is a team of 3 software developers and a set of faculty innovators We have since grown to a much larger space and a much larger team. So from the 3 people we had in May of 2015, we now have 16 full-time people working in the greenhouse, working on a set of, at this point, about 11 different projects, some very large, some smaller, some new, some are much more mature. So it was a kind of space and opportunity that our campus seemed to really need. A lot of energy and activity flowed into it. This space on the top of our library is now this big open collaborative space that you see here. We're actually in the middle of a renovation. And I just wanted to note with this slide that in addition to the 16 staff members we've hired inside the greenhouse, we also engage with a very extensive group of student fellows. And these students, for this kind of work, provide a really exceptional opportunity for drawing in resources. The students not only bring excellent technical skills to this kind of work in software development and design and user experience work and so on, so they bring their own skills that they're learning, but they also know a lot about the education space. So in the past, when I brought students into my astrophysics work, they have strong technical skills, but they don't know about my astrophysics work when they come to start with me. Here it's different. It feels very different because students come to the activity with a lot of knowledge, with in fact expertise in a way about what's happening on campus. So we have 18 student fellows. They're really interns. They just like to be called fellows because it sounds more dramatic than being called interns. We're happy to accommodate that. And they do a lot of important work for us. Opportunity, of course, exists on every campus, and so I would strongly encourage anyone who's thinking about doing this kind of work to look very clearly and as aggressively as possible towards students as an engine of creativity. Okay, we have a whole bunch of different tools that are working inside the greenhouse now, and I'm going to spend a few minutes talking about each of these 6 products or projects that I have up here on the screen. I just wanted to say that we have been able to attract substantial funding, both internal funding for some of these projects and also quite a bit of external funding for these projects. That external funding has been both for the development of the projects and for research that is done on the back of these projects, research that is enabled by these projects. And so both things have gone together in enabling us to come up with the funding we needed to create a portfolio. So I'm going to take some time now to talk through each of the 6 projects that you see right here. I want to first talk about a very simple project, but one which I think has a lot of power and should be implemented very widely in higher ed. It's something we call the Academic Reporting Toolkit. And its purpose is to move to the left-hand side of that information agency spectrum I talked about earlier and put information into the hands of students and faculty and staff who need to make decisions about what's going on in higher ed. We have this information sitting in a data warehouse. We should, as a start, at least make it available to the people who might be able to put it to use. So that's the idea of academic reporting. Give people the data, let them make decisions. This ART 2.0 tool grew out of work that my colleague Gus Everard here in the physics department started in 2006. Opportunity that was created by having a large data warehouse and built a first version of this academic reporting toolkit, ART 1.0, in 2006. This one was directed toward faculty and staff and provided a bunch of information about courses to those audiences so that they could better see the history of what was going on and be able to more quickly and easily make decisions about the future. That tool, there's a fascinating story behind it because it was kind of, access to this kind of information was kind of novel on campus at the time, and some people were uncomfortable about it. For example, with the idea that one faculty member might be able to look at the grade distributions given out in other people's classes, right? So the tool kind of languished for a while because the campus had to get to a place where they had a more, I would say, a more modern understanding of information openness and its benefits so that they could recognize that those benefits might be substantially larger than the potential drawbacks of providing access to information for people. So in 2015, when we launched the greenhouse, we started working on developing not only faculty-facing tools, but also student-facing tools. It's all the information that we have, first about courses and eventually about other things. So right now we have an ART 2.0 tool that was released in March of 2016, the initial version of it. It provides students with information about, and the kinds of information it gives are things about what have students said about this course in the past, what do faculty members say about this course in their course descriptions, what's the enrollment patterns of this class, who takes these courses, so are they freshmen or sophomores or juniors or seniors, what courses do they take before they take this, after this, what majors do they go on to major in, what courses do they take in conjunction with this course, co-registered with, and so on, who has taught this course in the past, all this kind of information that's sitting in the data warehouse that might be useful for students trying to make decisions about whether to take a course or not, or whether to take it now, whether the course seems like one that's right for them. Very quickly, within the first month, there were more than 5,000 student users for this. There's a lot of interest been spread through our student newspapers, the Michigan Daily, and our Central and LS&A student government, and so on. The interface is a pretty simple one. It creates kind of a baseball card for every single course that exists on campus. This interface looks the same for all of the 9,200 courses on campus, so students can learn to read it and to extract the information they want from it. You can see it has some course evaluation data summarized on it, information about instructors, and all the other things. The future of this tool is to expand to other kinds of information. So right now it's providing information about courses to students, and that's a great starting point. But we would also like it to provide information about things like courses of study, academic majors and minors, so that a student might say, I'm thinking about majoring in biology. Let me see what that looks like. What is the kind of pathway people take through biology? And where do I stand on that pathway? Which parts of that path might I have already accomplished? What would remain for me to do? What might be the order in which people typically do that, and so on. Courses of study would be one. Another example is they might be interested in reports about themselves, for example. Tools that would enable a student to understand their own progress and performance in comparison to other groups of students that they might choose to compare themselves to. So for example, they might be comparing themselves to students who have already accomplished a goal that they're trying to accomplish. Or they might be interested in comparing themselves to people who arrived on campus with backgrounds similar to theirs. There are sort of different reference points that you might choose to make as a student, and we would like to allow them the opportunity to explore those kinds of things. We're also implementing a project now called the Transcript of the Future Project, which is going to use this platform to allow us to display to students 4 or 5 imagined possible future transcripts, different ways of visualizing experience on our campus. And we're going to use this opportunity to allow us to put those in front of students and let them reflect on them and see which ones they think would best share the nature of their experience, both for themselves, so that to help shape that experience, but also with external audiences like graduate and professional programs or potentially. A general reporting tool made available to everyone on our campus, taking advantage of the data that we have. A second tool, and one that I work on very extensively, is the eCoach project. eCoach grew out of a vision which was literally in front of me when I was teaching my classes. So I regularly teach big introductory physics courses to 700 students. Learned by using data that all those students were really very different from one another, and that ideally I would be able to interact with those students in very personalized ways that are sensitive to their background and their interests and their goals and their current state. The challenge was I didn't have a practical mechanism for doing that. And eCoach is an effort to use computer-tailored communication to fill that gap, to enable us to have some opportunity to interact in a relatively humane, conversational kind of way with students in a personalized way, even at scale. So that's what eCoach is all about. The way eCoach works is it's built on a core that you see in the bottom center of this figure, tailoring system. And MTS is a mature open source software system that was built in our School of Public Health, tailored public health interventions. Right, to be able to speak to individuals about controlling diabetes, quitting smoking, making a cancer treatment decision, a bunch of public health kind of circumstances in which they wanted to communicate with people in ways that are tailored based on their background and current state and future goals. So very similar problem in a different context. And we adapted MTS for an educational context to build the eCoach system. I should say that nothing that happens here is artificial intelligence or anything else. The way this works is you gather the expertise of dozens of instructors and also hundreds of students who've experienced this educational environment. You get them all to talk about what kinds of behaviors led to success, and then you feed that into the system and use it to coach students toward their future success, right? We work with the behavioral scientists in our team to craft those messages in ways that adjust what we would say to students, of course, changing the content, but also adjusting how we would say it to students. We might deliver the message in different ways to different kinds of students, and even changing who says what we're saying. Turns out that computer-tailored communication researchers have shown that the voice in which a piece of expertise is delivered changes its adoption enormously. If an expert like Professor McKay says you really need to start studying 10 days before the exam, students feel advice because they believe I don't really understand who they are or what their lives are like. If they instead receive that same advice from an identity salient peer, someone who's quite close to them in background and interests and goals, like their roommate, for example, they are much more likely to adopt that advice. And so we use testimonials, identity matched testimonials extensively in this system. So the expertise comes in from the top in order to create the messaging. Detailed information about every student comes in from the left, and then what comes out is individually personalized messages. The right message for the right person at the right time. Just to give you a sense of the kind of main interface they see. So they see an interface that begins looking something like what you see here. It is speaking to them of things they might be thinking about at this current point in the context of a course. This is a course coach for a big statistics class that we have. It's providing them with access to ideas about what they might be doing, messages about how to do different kinds of things, the opportunity to set up challenges for themselves, and so on. It's a coach that aims to work them towards success in this class. Evidence that eCoach improves student performance in courses across an array of different courses. The results that are being shown here are actually kind of older ones. We have a bunch of new stuff that we just haven't put together in publication yet, but it's quite consistent with this. When students use these tools extensively, they can improve their performance, even accounting for all the elements that we know about their background. They can improve their performance by anything from a few tenths to a half a letter grade. So we have many goals for eCoach, and they're not just improving performance. Improving performance is a good baseline for success for these tools. It's certainly one of the things that we aim to do is to improve student performance. We also would like to improve affect and longer-term learning and help them experience these courses in a much more positive way and so on. Okay, so that's eCoach. A third important tool, which has been created by my colleague Barry Fishman and one of his graduate students, Kate Holman, who's just about to graduate, is called Gradecraft. And Gradecraft is it's almost a learning management system for supporting game-inspired courses. So it aims to bring a gameful pedagogy to learning. The idea of gameful pedagogy is to focus on creating a classroom environment in which autonomy plays a really central role, in which you both support the growth of and reward competence, and in which students feel a really strong sense of belongingness. And if you can kind of lie at the intersection of those, as you see in this diagram, what you get is a lot of intrinsic motivation. Students doing things that are really challenging and difficult in an engaged and extensive way because they want to, instead of because you've somehow forced them to. So there's a lot of interesting work going on around gameful design, and many of those elements have been incorporated in the Gradecraft vision, and the tool has been built to try and support this sort of gameful pedagogy. The Gradecraft interface is one that allows both students and faculty to keep track of a system that provides a lot more autonomy for students, a lot more choice. Since students are making different choices, there's kind of a bookkeeping challenge for both the faculty and the students to understand, and Gradecraft has been created in a way that aims to support that kind of understanding, clear understanding for everyone who's involved in the course. Gradecraft has a very promising future. I think I have taught in this way, and I really don't want to go back to more traditional modes of teaching. I wanted to mention that the instructors of the creators of Gradecraft are now teaching a MOOC that's on edX right now. It's on gameful learning, and it launched just a little while ago. They're also beta testing right now commercial access to the Gradecraft tool. They have a bunch of trial accounts and a group of people who have actually purchased accounts and are using it in places as widespread as Tasmania. So they're beginning to turn it into something that might be something that could be really used at scale even beyond our campus. There are a lot of difficult things to do with a tool like this, and that's why it's important that it should exist not merely as something sprinting toward commercial application, but something that can continue to live in a real R&D environment, deeply engaged with non-commercial faculty-driven research so that we can really get it right before we try to imagine it as a fully commercial kind of activity. Okay, so that's Gradecraft. That's 3 of the tools. Let me talk about 3 more. Problem Roulette is perhaps the simplest tool we use, but it's one that's been very effective on our campus. It grew out of my colleague Gus Everard's realization that in our introductory physics courses, what students want to do and need to do to practice for exams is to do a bunch of old exam problems. And we would always give out 1 or 2 practice tests for them to work on. But some students had access to many practice tests, basically because they live in fraternities where they have gathered up those practice tests over the years. And that felt like an equity issue, plus it was just generally the case that we wanted to give everybody lots of opportunity to practice. So Gus built a very lightweight tool called Problem Roulette that allows students to call up more practice tools, sort of random within topic access to a library of local past exam problems. And that fact that the problems are real exam problems from our own classes is viewed as very valuable by students. There are all kinds of sources for practice problems in textbooks and so on, but students always feel that those problems are not well matched to the ones that will be asked on the exam. So they really like the authenticity of these problems. He launched this in 2011 in a set of introductory STEM courses, and now there are about 15,000 study sessions a month, and in a typical course like our general chemistry class, the students in that class in one semester might do 120 or 130,000 practice. Extensive use by students. They find it very valuable. This tool was originally built in Gus's research group by an undergraduate student who wrote the code, and it works, but it's not optimal. And so we've now brought it into the greenhouse so that we can mature it and actually connect it to some of the other tools that we have like eCoach. So you can start to get a sense that with a tool like this, you could think about all kinds of gameful modes of encouraging students to participate, different forms of leaderboards or competency measures and things like that. And we're gradually building those into the system as well. The future for Problem Roulette, we're thinking a lot about gameful support for them. There are strong synergies between tools like Problem Roulette and eCoach. And we're thinking about using it in contexts that go beyond the courses. So for example, a large archive of real University of Michigan test questions might be quite valuable to high school teachers who aim to prepare their students to come to the University of Michigan and be successful, for them to be able to see what are we really asking our students to be able to do at the end of a semester of physics goalpost for them, and one which might be very valuable to share. So that's Problem Roulette. Pretty simple, but a nice example of a straightforward feature. The last 2 projects are a little more research oriented at this point, and I would say potentially very powerful and elaborate. One of them is called MWrite, and MWrite is a project being led by the Sweetland Center for Writing here at the University of Michigan. It aims to infuse in the largest classes on our campus writing to learn pedagogies. So writing to learn is distinguished from learning to write. The point of writing to learn pedagogies is to get people to engage in authentic, effortful writing so that they will learn a subject, not necessarily so that they will learn how to write. They will probably gain some skill in writing in doing this, but the focus isn't on the writing, the quality of the writing, the focus is on the quality of the understanding of the subject matter. So very often in large classes, we don't ask students to write because we don't have good ways to interact with that writing. And consequently, we don't get to take advantage of the powerful affordances of writing to learn pedagogies. So MWrite aims to create tools that will make it easy and effective to use writing to learn pedagogies even in our largest classes. I'm personally very excited that the Sweetland Center for Writing is leading this project. They have enormous expertise in writing pedagogy, and having them at the center of this technology-oriented writing project ensures that we will bring the best of that kind of expertise and sensibility into this project, which might otherwise be done at a kind of superficial technical level. So the vision for MWrite is to support writing in large enrollment courses. It also, in the course of doing that, creates large corpora of student writing, which provide a great basis for research into student understanding. Imagine in an introductory physics course that I ask all of my students, 700 students, to write me a paragraph or two explaining their understanding of some element of Newton's third law. I will then have a corpora of 700 students writing about this concept. And I can begin to use that information to better understand student learning. So really powerful research opportunities associated with this. There are two big approaches to making students, enabling us to interact with student writing adequately to get them to engage in an authentic way. One of them is to use automated peer review. And peer review works well for scaling because anytime you have more students, and students are the ones who are evaluating the students, so that works well. But we're also using automated text analysis and natural language processing approaches, which aim to provide actionable information both to students, but also to instructors. So right now, MWrite is being used in a number of these large courses: introductory economics, introductory chemistry, and a couple of smaller material science and other courses. They have built their own peer evaluation tool, not so much because the ones that exist aren't good. There are so many good features in existing peer review tools, but they really needed to be able to get in under the hood and make changes because they want to do a series of experiments with peer evaluation. And so they've built their own peer evaluation tools. They're also now beginning to connect natural language processing to those tools. It's very exciting for me. I think there's a lot of work going on with peer review enhancement. And also, we're just now starting a bunch of work on trying to use natural language processing to extract meaning on all different timescales from this writing and be able to put that back to work in the classes. This is an area where I don't have a lot of expertise, but I have a lot of excitement. And so I'm actually quite enthusiastic to collaborate with the people who are involved who do have the natural language processing and automated text analysis expertise so that I can think about and learn more about how it is we draw meaning from data like text. Okay. And the last tool I want to mention is one that came into the greenhouse in a slightly different way. All of the others had some technical maturity before they arrived on at the greenhouse's doorstep. Policymaker entered as an idea, not as a piece of software or tool. Role-playing can be a very powerful pedagogy, and one of our instructors here in the Ford School of Public Policy, Liz Gerber, has been using this kind of simulation pedagogy in a really big way in the Ford School for a long time, but always supporting it with paper technology. What the vision of Policymaker is to create a platform that allows educators to both create and implement really rich and complicated simulations in their classrooms or even outside the classroom. It provides people with customized role-playing simulations that lead to the kind of engaged learning that's really, really great to see. And they have now built this platform and used it for extensive weekend-long simulations at the Ford School, where they might, for example, have a few hundred people engaged in simulating the creation of a bill for the Michigan legislature, where there are people who are legislators, people who play roles in regulation, the governor, but also people who might be there as lobbyists or citizens concerned with this legislation. Everyone has different roles to play in the creation and emergence of a bill like that. And it's all supported on this platform, which you can see has a bunch of different groups and roles that exist, and the people who are playing those roles, a schedule for all the events that are going on in this real-time simulation and so on. They just ran a big simulation in January. It was really fascinating to watch it happen. We gathered, of course, in the course of that, a lot of data as well to help us understand how the simulation played out and what we might do to improve the support of it using the Policymaker interface. Okay, so the future for this, obviously, is to learn from these early exercises, and now we're starting to think about a wide range of potential future applications for this kind of simulation pedagogy. Another really exciting way in which technology might enable people to do something that was very, very difficult in the past in a much easier way. Okay, so in general, what we're trying to do here in the Digital Innovation Greenhouse is to take advantage of the fact that we're now educating people in an information age, to put data in people's hands in a bunch of different ways, right? to give it to them more or less directly with something like the Academic Reporting Toolkit, or to massage that data under expert influence and provide them with feedback, encouragement, and advice in a tool like eCoach, or just to handle the data that enable people to do a more complex and perhaps engaging pedagogy like gameful learning or simulation pedagogies in the policymaker tool. What the greenhouse has become is really an educational R&D lab. It brings together really focused applied education research with product design in a very integrated way, so that the design team is able to learn from the research and the researchers are able to take advantage of the work the design team has done, both creating a kind of closed loop between research and practice, so that each semester we can be doing a new series of experiments in this environment and learning from it. We're creating the kind of learning laboratory that we imagined the university might be, and putting a kind of focal point here. We've learned a lot of things from the first 2 years in doing this work. First of all, it's a deeply collaborative activity that we need to engage in, that draws both on faculty and staff, but also on students. And in between the two, the development and design professionals that DIG employs. We've also learned that this is a difficult thing to do. It is not something that you can work everything out in advance. It takes a lot of time to build trust among all of these different stakeholders. It takes a lot of effort around innovation advocacy. You can't just assume that you'll build an open education resource and have everyone jump on it and use it. You really need to work on spreading it. And it also, of course, takes resources. It takes money, it takes space, it takes data. And having good mechanisms for gathering and putting to work that data has been crucial for us. We're really benefiting from the last 6 or 7 years of institutional scale work to open up and think about the processes we use to provide access to data on this campus. That innovation is always done by people, and the relationships that are involved need lots of care. It's also enabling traditional research, which has connected us to existing resource and reward structures. So we can get faculty members to work with us because they're doing research. That counts just as research always has counted, and in fact gets funded just as research always has been funded. And the last lesson I would say is that we had the good fortune of starting off fresh in a new space, not as part of something that already existed, but in a space that allowed us to imagine what we might be and to create a new kind of future. And that was a major advantage for us. And I'm going to stop there and just go back to the Hangout and see if anyone has questions they'd like to ask.
Thank you so much. That was extremely interesting. Shri, do you know if anyone has posted questions online?
Yeah, so I've got 3 questions here. I'm going to ask them now. The first question is, apart from the data and the research, are you also cataloging the practices and the model of DIG so that you can share that with the rest of the world?
Yeah, I mean, that's a great question. It's something that we're gradually getting better at. Many of these things we've been kind of inventing on the fly, but one of the things we learned very quickly is that, and it's obvious, of course, but the more richly you instrument the tools that you're using, the more richly you can understand which elements of those tools lead to impact, and which pieces of it people themselves believe are useful, demonstrated both by their engagement with them, but also by potential measures of impact that it might have. And so each of these tools has gradually become more richly instrumented in the sense that the tools themselves gather lots of data about what's happening. Included in that is gathering the authentic product of student work. So I mentioned that perhaps most clearly in the MWrite case, where student learning or student writing and the corpora of student writing provide this great body of evidence for what's been going on. Very rich, not necessarily easy to analyze, but to be gathering it provides the opportunity to learn much more complex and rich things. And I guess the last thing I would say is some of these tools are really communication tools that go back and forth with students, like eCoach. And so eCoach is able not only to draw on the data we already have about students, we can communicate with and go back and forth with students and learn from them things that we might not otherwise know about them. And a very simple example of that in my own context would be to learn about a student's affect toward my physics class. It's widely the case that students arrive in a physics class some students with a sense that they're not a physics person and they might never be able to learn physics, right? And if they have that sense, I really need to communicate with them about it, because if they stick to it, it's going to be very difficult for them to learn. And that's a shame. I would like them to get over that. So, you know, we can communicate with them about it and learn more about it.
Thank you. The second question I have is, have there been any efforts to share some of the data sets beyond University of Michigan? And the person who asked the question recognizes that there might be issues around privacy and things like that.
Of course, there are issues of privacy and things like that, but they're not, necessarily impossible to get around, right? We all have engaged in research projects that span across institutions, and if we use the mechanisms that have been created around the research community for protecting personal privacy, for informing participants in research projects about the nature of the research that's going on and receiving their consent, it's perfectly possible to create research projects that can work with collaborators across multiple institutions. We already have a set of collaborators around several of the research projects, particularly the research projects, that kind of installs naturally in them the development cycle for handling those research ethical protocols. Some of these researchers are people who began their research with us. So we have several people who have completed their PhD projects doing this kind of work, now have moved on to assistant professorship roles around the world, as it turns out. And the laboratory we've set up here remains a powerful tool for them. And they can continue to do the research that they began in our laboratory because we've set it up and instrumented it in this way.
Right.
And that has benefits for us as well. There are many research topics in this kind of space, and no one has enough energy to be able to ask and answer all the questions that you might. So I love the idea that we might be able to, at some level and with appropriate care, open this laboratory to researchers who aren't only on our campus and make it possible for the larger community to learn from the experience that's happening here at Michigan.
The next question I have.
Our last question.
Yeah. So the next question I have is, are there any interesting projects that came out of the MOOC community?
That's a great question, and I didn't talk about it here, in part because my own personal focus has been on the on-campus experience of our students, particularly in large-scale educational environments like these large introductory courses. That's not because MOOCs aren't interesting. It's just because there are only so many hours in the day. And so my own attention has been focused in the on-campus community. We do have a group of researchers here on campus that are both engaging in MOOC research, especially around the work of Chris Brooks in our School of Information, and his students and postdocs. Stephanie Teasley has done some work on MOOCs as well here at Michigan. It's a kind of growing exercise as well. We also, in the greenhouse, have a project called the MOOC Tools Project, which aims to create new tools that we would use in MOOCs and to treat those tools in kind of the same way we're treating the on-campus tools. So to instrument them for research, to make them available to researchers to be able to do the kinds of projects we're doing and so on. It's just another branch of what's going on in DIG, and I just didn't have time to talk about it.
Well, that's very exciting. Thank you so much. And I'm sure many of our viewers will be watching this later also. And so you may be getting some emails with additional questions.
Sounds great. I'd be happy to do it. Okay, bye-bye.
Thank you so much for joining us.